Welcome to Virtual Pathfinder YouTube channel. In this video we will have a look at some video clips of Saturn shot last week. The equipment used was a Micro Four Thirds crop sensor camera attached to a Celestron C90 telescope. The tracking was approximate, using a compass when aligning the axis of rotation towards the north celestial pole. The rig was built using a photography tripod, using a Vixen Polari star tracker with a counterweight. The viewing conditions were not optimal since the planet was very low in the sky. There was air turbulence from buildings under the line of sight. A ZWO atmospheric dispersion corrector was attached, but it was hard to tell if it was at the optimal setting. Saturn has a diameter approximately 10 times the diameter of Earth. It rotates rapidly, with one day being just over 10 hours. Due to its distance from the Sun, Saturn's orbital period is longer than Earth's, making one Saturn year about 30 Earth years. It takes the light from Saturn about 75 minutes to reach Earth. That is about twice the distance to Jupiter. Since Jupiter is about the same size as Saturn, it appears almost twice as large in the sky. Saturn has at least 82 moons, where Titan is the largest. At the end of video clip number 2, there is something that could be a moon, although I doubt it's possible to capture it with this telescope. But in case it is a moon, it would likely be Titan. This is how an unprocessed video clip looks like. Here are some data about the image capture. As mentioned, it is shot using a mirrorless Micro Four Thirds camera. The smaller sensor makes the image look 2 times magnified compared to using a full-frame camera. The camera was also set to use a digital teleconverter, further magnifying the image by a factor 2. Although the image gets larger, there are very few pixels in this image. Saturn's angular size is about 20 arc seconds. At this focal length, when using a Micro Four Thirds sensor, that corresponds to about 25 pixels in diameter. That may seem like an impossible situation, but it is actually possible to work in post-processing to get many nuances and details out of those pixels. In this video I have tried out various post-processing methods on several video clips. I will not go into detail of these 7 post-processing settings, but in general I can say that I have used all the tools in the toolbox. Adjustment of contrast, brightness, colors, and also added some color filters to bring out low contrast nuances. It is worth noticing that the raw material also had a variation in quality. Considering the small number of pixels to work with, I think the results are good, especially clip number 5 to 7. The last clip is one video clip stacked in 3 layers, where the 2 layers on top are shifted ±1 frame to average out noise. The light from the sun comes from beneath Saturn, making it look interesting. The image is shaky in some of the video clips due to the windy conditions. The magnification makes the setup very sensitive to the slightest movement. In the third video clip, I used a color grading filter I have created for more cinematic video use, but I tried it out to see what effect it could make on the final image of Saturn. Clip 5 and 6 has more red and blue color grading. Perhaps these are my favorite among these clips. Clip 7 is, as mentioned, a stacked video clip reducing noise. Considering the small number of pixels, this is as good as it gets. I hope you enjoyed this video. If you're interested in more videos like this, remember to subscribe to this channel. I will make a test to stack frames from these clips in Lynkeos to see if I can reduce noise and get some more detail out of these clips. Until then, have a nice week.